Hello everyone. So we have a question here that which is the correct statement about the NiN bond in NiNH3 whole 6 2 plus. So we have a complex here, nickel complex, hexamine nickel plus 2, and we are being asked to mention that out of these 4 statements, which is the correct statement belonging to this complex. So statement A says all bond lengths are equal. Statement B says the 2 axial bonds are longer than 4 equatorial bonds. Statement C says the 4 equatorial bonds are longer than the 2 axial bonds. And statement D says none of the bond lengths are equal. So we are being basically asked about the metal ligand bond. Okay, so central metal ion is nickel, and then we have the ammonia's nitrogen bonded to it. So it asks that in this octahedral complex, so we have 6 ligands and octahedral complex we have. So basically the structure should be something like this. Okay, so octahedral structure we know already how it looks. So 4 ligands at the corners and then 2 in the axial positions, up and down, and these corners are known as the equatorial positions. So here let's imagine here we have NH3, 6 NH3 ligands attached to nickel, okay, Ni. So this is the central metal ion nickel, and here we have NH3, NH3, 6 NH3 in the octahedral geometry. Now they are asking that whether any of these NiN bonds are longer or shorter or all are equal. Okay, so we know from our knowledge of crystal field theory that longer and shorter bonds exist only when there is a distortion in the regular geometry. So if the regular geometry deviates from regular octahedral to either tetragonal or square planar, then only we have this kind of longer or shorter bonds. So we are basically being asked that whether this octahedral complex will show any deviation from its regular geometry, and on what conditions this deviation will occur. It will occur only if we observe Jahn-Teller distortion that we have discussed in our previous questions when we were solving these questions on Jahn-Teller distortion. Then we saw that deviation from regular geometry occurs only when there is distortion due to Jahn-Teller effect. So mostly what happens, the axial bonds they elongate or axial bonds they shorten. Okay, so basically what we have to check out in this question about the filling of d electrons in the central metal ion. Okay, so let's see that in nickel in the ground state has 3d8 4s2 valence electronic configuration, and now nickel in this complex has a +2 oxidation state, so the valence electronic configuration becomes 3d8, no electrons in the 4s orbital. Okay, now we have to arrange these d8, 8 electrons in the T2g and Eg orbitals. And before arranging these electrons, we have also to take care about the nature of the ligand. So ammonia, here we have ammonia as the ligand, and particularly in this complex, ammonia will be acting as a weak field ligand. So we know from the spectrochemical series that ammonia is mostly an intermediate ligand. So it can act as a strong field ligand in complexes where the central metal ion is in a higher oxidation state, +3, +4, +5, like that. Okay, and it will act as a weak field ligand in those complexes where the central metal ion is in the +1 or +2 oxidation state. So in this particular complex, ammonia acts as a weak field ligand. That means this complex is a high spin complex, and because of this there will be no pairing of the electrons. So the filling will occur following the Hund's rule. So each orbital containing 1 electron each. So 3, 4, 5, and then pairing will start 6, 7 and 8. Okay, now after filling these electrons, we have to check whether these are symmetrically or unsymmetrically filled. So T2G has 3 orbitals and 6 electrons. So this is symmetrical filling of T2G orbital. And then Eg is also symmetrically filled Why? Because Eg has 2 orbitals and there are 2 electrons. So this is again a symmetrical filling of Eg orbitals as well. So both T2G and Eg are symmetrically filled. So what should be the conclusion? So there shouldn't be any Jahn-Teller distortion. And that is why, since there is no Jahn-Teller distortion, there is no deviation from the regular geometry. So this complex remains octahedral. There is no deviation because there is no Jahn-Teller distortion, and that is why, since it stays in its regular ideal geometry, so all of these nickel and ammonia bonds, so nickel nitrogen bonds, are all equal in this complex. So the correct answer for this question will be option A. All bond lengths are equal. Why they are equal? Because this complex is a regular octahedral structure, because there is no Jahn-Teller distortion observed and there is no deviation from the regular geometry. So before I end this session, one important thing that I want you to remember, that for D8 complexes, that is for complexes where the central metal ion is like nickel in the +2 oxidation state with D8 configuration, then irrespective of the nature of the ligand, or you can say irrespective of the nature of the complex, whether the ligand is a strong field ligand or a weak field ligand, or whether the complex is a high spin complex or a low spin complex, the filling of electron in the D8 configuration is similar, and also this D8 configuration will not show Jahn-Teller effect. So why is that? Let's see. Now in the high spin configuration, that is when we have a weak field ligand. Okay, so in case of a high spin complex having a weak field ligand, then how these are filled? So we know that for high spin complexes there is no pairing initially. So the D8 configuration is something like this: singly occupied first 1, 2, 3, 4 and 5, and then the pairing starts in the T2G orbital. So 1, 2, 3, 4, 5, 6, 7 and 8. So the configuration becomes T2G6. We have 6 electrons in T2G orbital and Eg2. Okay. And also you can see here that T2G is symmetrically filled, 3 orbitals, 6 electrons. Eg is also symmetrically filled, 2 orbitals, 2 electrons. So none of these T2G or Eg orbitals are unsymmetrically filled. That means this D8 configuration in the high spin will not show any Jahn-Teller distortion. Now let us see what happens in the low spin configuration. So in the low spin configuration, we know that pairing will occur. So that will start from the T2G orbital itself. So 1, 2, 3, then pairing occurs 4, 5 and 6. Okay. And then 7 and 8 in the Eg orbital. Now, if you look at it carefully, then you can see that here also we have got a similar configuration of T2G6 and Eg2. That means 6 electrons in T2G and 2 electrons in Eg. So, there is no difference between the filling of electrons in the D8 configuration in the high spin as well as low spin complexes. So, whether the ligand is a weak field ligand or a strong field ligand, the filling of electrons in the D8 configuration is similar. And as you can see, both the T2G and Eg orbitals are symmetrically filled. Therefore, this D8 configuration does not show Jahn-Teller distortion. So this you have to remember for the complexes where the central metal ion shows a D8 configuration. That irrespective of the nature of the ligands and the nature of the complex, the filling of electrons is similar. Both the T2G and Eg orbitals are symmetrically filled and D8 configuration shows no Jahn-Teller distortion. So I hope this explanation is clear to you. If my videos are helpful to you, please like, share and subscribe, and please let me know in the comment section what you want to learn next in chemistry. Thank you so much.